And so, Greg, if you want to go ahead and get your presentation prepped, you should have co-hosting privileges, and I'll go ahead and introduce you. So, Greg Nowacki was born and raised in Wisconsin's Northwoods and attended the University of Wisconsin-Stevens Point, where he received bachelor's and master's degrees in forestry and natural resources in the mid-1980s. Afterward, he went eastward, successfully getting his PhD in forestry at Penn State University. And his graduate studies were keenly focused on oak ecology, relating changes in oak abundance to land use and fire. Immediately after college, Greg served as an old growth forest ecologist with the Nature Conservancy for 2 years prior to signing on with the U.S. Forest Service in Alaska. Greg transferred to Milwaukee, Wisconsin in 2001, where he presently serves as the regional ecologist and soils program manager for the Eastern region. Throughout his career, Greg has dedicated his work to facilitating the transfer of science to land management.
All right, do you hear me first and foremost?
Yeah, crystal clear.
All right, number 2, share screen. I'm putting that up. I have one participant can share at a time, multiple participants can share simultaneously. The latter is checked right now. I'm trying to get my screen up.
Oh, that looks like, yeah, great. We can see your PowerPoint screen now.
All righty, thank you so much. Here we go. Okay, everything good? I'm not going to share the video, spare you guys of my face here this morning. So, presentation as introduced, oak fire and climate change, the profound effect of changing conditions on the oak resource. Thank you for the introduction. Got a lot of information here, so everybody open up their gray matter. It's going to be a fire hose of information coming your way. Main objectives of today's presentation. We're going to establish the historic relationship of oak and fire. We're going to document the profound effect of land use change in fire suppression policies that we currently endure. And lastly, we'll project possible effects of future climate change on the oak resource. I want to thank Patricia for your lead-in presentation. It was great, and it's going to fortify this presentation today. So exactly, what is the problem here? It's basically the lack of oak regeneration and the overall demise of oak ecosystems. And this is ubiquitous across the eastern United States. So it's probably best to start at the beginning. One is that, let's look at pre-settlement conditions. When we think about oak-dominated ecosystems or oak pine systems, historically, they were not necessarily forests, closed canopy forests, but they're more woodland-ish, right? Scattering of trees, sunlight penetrating down to the forest floor, and less density than what we see today. Moreover, lacking often. So in order to quantify conditions of the past, we can turn to studies that have documented density, diameter, and basal areas based on witness trees. The witness tree databases, unfortunately for you, but it comes out of the Midwest. So you can see a series of studies here from Illinois, Wisconsin, and other states. The things that I want to point is that historic densities of our pre-settlement oak-dominated stands tended to be low. The diameters themselves were high, and I see my internet connection is unstable. Whoops, that's frightening. Combined together, these two parameters afford for a lower basal area than expected. In the diameter distribution, basically was quasi-even. Small, medium, and large stems occurring. Again, here, since we were dealing with woodland conditions, there were highlight conditions affiliated with that, right? So you had sunlight penetrating down through the overstory into the understory. That made for a very robust, a very diverse understory made up of grasses, forbs, which will appear momentarily. There you go. A lot of information on these screens. And lastly, a grand shrub component, blueberry, raspberries, huckleberries, all those good things. So this is how conditions were quite often in the pre-settlement forest. Woodland conditions, lower stand densities, robust understories made up of these life forms. One thing I want to emphasize is greater than 80% of total plant richness comes from the ground flora layer. This is where it's at. What happened along the way? Well, we had Europeans that came on the scene, and we had the great cutover that took place. We had larger trees that were cut down, boughs extracted for timber resources, of course, and we had some regeneration that were left on site, smaller pine trees and oak trees that you see here. Well, it wasn't just a great cutover that took place. Most landscapes, they were followed by the burnovers, right? So we had a lot of slash on the ground, new ignition sources, and these systems indeed burned. But they affected the regeneration layer differently. The larger oak individuals, some of them were spared just because they were large enough, they were armored, they were able to tolerate that fire. The pine regeneration absolutely got hammered just because by and large, they don't have the ability to sprout. There's some exceptions to that. Pitch pine is one of those, but for most of our pine species, they were directly, their death took place immediately after those burns. And the individuals that were top killed that happened to be oaks and hickories and chestnuts at the time, they resprouted along with the larger stumps that were left on site. So for forest recovery, oaks benefited tremendously from the great cutover and the great burnovers. Whereas pine, well, if you had some seed trees that were left behind, they were able to regenerate by seed if there was a long enough hiatus between fires that took place, because many of the burnovers were repetitive, of course. So these systems grew over time into today's conditions, but today's conditions are very different than what they were in the past. We know that the composition has changed tremendously, shifted largely towards oak, less towards pine, based on what I just explained. Another thing is just the structure itself. These are the same studies I had on before. Within a larger column, you have two columns. The first information is pre-settlement. The second column represents current conditions based on FIA. Density-wise, we have a tremendous increase that has taken place over time. Diameters, the average diameter decreased. That's not surprising when you're dealing with secondary and tertiary forests that we now occur in the landscape. Now, combined together, basal areas have actually increased. We think, of course, it's mainly because of this huge increase in stand density. And there's been a dramatic change in diameter distributions going from this quasi-even to a strong inverse J-shaped curve dominated by small stems today. So in summary, what has happened over time, pre-settlement to present day, we see this large increase in tree density anywhere from 2 to 10x. We have a decrease in average tree diameter, again, not surprising, anywhere from 10 to 20 centimeters less. Coupled together, there has been an increase in basal area. And lastly, this dramatic shift away from this kind of quasi-even distribution of small, medium stems to one that's inverse J-shaped, loaded with small and medium-sized diameters of today. So tremendous shifts, both compositionally and structurally. Now, under today's low light conditions, what has happened? Well, the first life form to wink out are your grasses, just because they're very much dependent on high light conditions for survival. Next are our forbs. They have a little bit more energy in their root systems, able to eke it out a few years, but eventually they succumb. And lastly are the big guys in the understory, at least regarding these life forms, that is the shrubs, last to go. And what are you left with? Well, a leaf layer, basically. I've been from southern Minnesota across through Wisconsin, Indiana, Ohio, to southern New England, south to Carolinas, westward again through Kentucky, Tennessee, Ozarks, Ouachitas, back up to the Wisconsin area. Same scenario. We have a closed canopy overstory of oak, and the understory is largely leaves. That's all I do is kick leaves, I swear. And the few species oftentimes that I see occurring are exotics, right? Multiflora rose, honeysuckle, buckthorn, oh my goodness. So kind of depressing to see this condition, and also makes one, and at least scratch your head, from an evolutionary standpoint, how does this happen? Why would you have what's healthy oak ecosystem, right, down story with no ground flora? Something is awry. So anyway, going on, under today's low light conditions, our shade intolerant oaks and pines that basically ceased regenerating, whereas shade tolerant competitors such as maples, beech, basswood, they regenerate not only prolifically, but they successfully recruit these closed canopy conditions. And over time, they go from seedling to sapling, sapling to mid-story. And this, my friends, is the basis of mesification. This shift from xerophytic species, oak, pines, hickories, to these mesophytes, moisture-loving trees. So what's driving mesification? Note the large oak in the middle, surrounded by maples and other mesophytes. Oh, there's all sorts of things that have been thrown out there. Climate change, increasing precipitation or moisture, changes in carbon dioxide. These are the things that were spoke to earlier, of course. Nitrogen fertilization, that's all connected with climate change, directly or indirectly. Oak overbrowsing by our favorite little deer. Fire suppression, of course, in there. Even our poor little pasture pigeon has been implicated in this process. But when you look at the totality of all these factors, really there's one that rises to explain what is going on regarding the demise of oak ecosystems, and that's fire suppression. If we look at the area burned in the eastern United States, this is spanning from 1935 to roughly 1990. The area burned is on the side axis. We see back in the 1930s, roughly about 10 million hectares were burning annually. We see a substantial decrease in the 1940s into the 1950s, and basically baselining from 1960 outward. And why this dramatic decrease in fire? Well, we postulate that it's mainly due to post-World War II deployment of men and materiel to fight these fires. And they're you can see that it's bared out in the numbers here. So there's a reciprocal relationship between the importance of fire and mesification, right? So in pre-settlement times, back in the 1800s, before 1900, again, we had these open ecosystems of pine, oak, highlight conditions, a very diverse and rich understory of shrubs, grasses, forbs. Something happened along the way to paradise here in the mid-1900s. We have fire suppression that kicked bear policy, went strong. We all at once went from these open ecosystems to a closed canopy, and with that you had increased shade. And now you start seeing these little guys popping up in the understory. What are those? Those are your mesophytes. Now, going into today, we have this dramatic increase of shade-tolerant species that are occurring. So you have seedlings, and they're recruiting to sapling stage. And my computer is telling me my internet connection is unstable again. Wow, on a roll here today. Okay, now into the foreseeable future. We have basically decreased flammability due to mesophytic litter. We'll get into that shortly. And of course, because now we have these multiple canopies that have set up overstory and a dense understory or midstory of these mesophytes, we have these cool, humid microclimates that have set up. So getting fire back in these ecosystems when they're in this shape is really difficult. And as overstory trees, your oaks and pines start winking out, what happens? They're just merely replaced by these mesophytes. Okay, time for your ecophysiology lesson here, tying some of these things together. Oak indeed is a fire and drought tolerant genus that possesses various adaptations. Of course, it's a species known for its thick bark. It gets thick bark fairly young in age, and we think this is due to helping protect it from fire. It's a very able compartmentalizer and it's very rot resistant. So if the bowl itself is injured by fire, it's able to cope with that very effectively, changing wood chemistry. That's the compartmentalization factor. It over wounds very dramatically, very quickly. And due to its rot resistance, even if the bowl is injured, it's still able to maintain its tensile strength and remain living. Aggressive sprouter, we've already touched on that. We think this is a fire-based reproductive strategy. Very opportunistic, responds favorably to disturbance, likes high light conditions to regenerate. We touched on this before, fuel characteristics. We think that it actually produces fuels or products, materials that promote fire. We can look at coarse woody debris decay rates, comparing oak hickory systems to mesophytics, specifically beech and maple. And if we look at these decay rates, we know that oak and hickory decay very, very slowly relative to these mesophytes. Again, beech, maple, basswood. So these systems historically would stockpile fuels, basically, which is good for what? Good for fire. Leaf differences, oak hickory versus these mesophytes. Think about oak and hickory. Thick leaves, they tend to be very rigid. When they dry up, either on the tree or on the forest floor, they repel water very nicely. When they fall to the forest floor, oftentimes they're in a curled condition, making for a very aerated forest floor, which is very conducive to burning. Contrast that with mesophytes. Think about it. Thin leaves, very flaccid, have a strong propensity of clinging to water and staying moist. When they fall to the forest floor, they plaster themselves. Very little air is affiliated with those fuel beds. So is it no wonder what ecosystems burned historically and which ones didn't? So one more thing here, we'll just touch on the ecophysiology and the drought features because this is particularly important regarding climate change, right? So it's a very efficient water user, known for its drought resistance by and large, tap roots that exploit deep water sources. It's known for osmotically adjusting itself, changing solutes within its cells, able to extract tightly bound water from dry soils. And of course, it has these xeromorphic leaves that minimize water loss, and that's been touched on already. One thing that should be added here is it has a very thick cuticle layer, which prevents water loss as well. So since we're in West Virginia, thought that I'd share with you a little story from central Pennsylvania. This is based on my PhD work there. Smack dab in Pennsylvania, we have the Ridge and Valley province striking across from the northeast to the southwest. Of course, much of that continues southward into West Virginia, area where I did the work. A very interesting area. This is from a geomorphology standpoint. This is the area that's set up about 400 million years ago when the continent of Africa slammed into North America, forming these paralleling ridges and valleys. It's kind of like pushing a rug over a smooth surface, right? You end up with this type of topo roughness, if you will. Today, the ridges themselves that you see in the red are dominated by forests. The valleys, which are underlain by limestone are either in an urban scape or agroscape. So settlement times, what was there, and this is based on corner trees, witness trees that I gathered at Harrisburg. Yeah, those were oak, pine, hickory, and chestnut. Oak, pine, chestnut dominated the ridges, and oak, pine, and hickory dominated the valley floors. All of these genera, all four of them, are known to be pyrogenic in nature, so we think that fire was very important in the pre-settlement landscape, maintaining those genera. Exploitation of central Pennsylvania took place starting really in the mid-1700s and going like gangbusters until around 1900. This is what happened here is very typical over the eastern United States, and that is the extraction of the pine component. Pines made fine lumber, they're floatable, and so they were extracted off the landscape first and foremost. Remember, when these big guys were removed, you're removing your prime seed trees. So again, had a profound effect on regeneration that took place thereafter. Throughout central Pennsylvania, getting into West Virginia, oh my gosh, all the way up and down the Ohio River Valley, the production of charcoal for iron furnaces were huge. So loggers would go in, they would harvest vast areas of oak, hickory, chestnut. They would drag their bowls into and form these pyramidal piles that you see here, cover it with dirt, poke a few holes around the periphery and the bottom, light a slow burn, let it reduce to charcoal, seal it off, let it cool, dig it up, and transfer this charcoal to local iron furnaces to be used as a fuel for the production of pig iron. The amount of area that was treated in this regard is just unbelievable. We're talking about hundreds of thousands of acres, if not millions of acres throughout this area that were treated in this regard. The rapidity by which this took place was simply mind-boggling as well. Every 20 to 25 years, they would go in and harvest these stands. So definitely you're dealing with a coppice situation, right? Everything is predicated in sprouting. And where you have humans on the landscape, lots of slash that's left behind, guess what? Fire is there as well. So around 1900, there's change regarding the iron industry. We switched to fossil fuels as a fuel source, and these stands were left to mature, and that's what we see today. Along the way, chestnut blight hit, of course, removing that as a tree species by and large. Kind of eerie today, going out in the woods and seeing these old surrounded by mature forest. Can you imagine 100, 150, 200 years ago when you had a sea of humanity around this site? Horses and oxen bringing in charcoal, lime, ore, and and those same animals hauling out like pig iron from these places. So very eerie. Smoky Bear policy kicking in again early to mid 1900s. Just look at these 1 year alone. 1908, over 400,000 acres burned. And look at these decade-based, less than 4,000 acres burning over a full decade. So this is a reduction of over 1,000-fold regarding acres burned during this period of time, less than a century. And of course, with fire suppression, we're talking about these fire-sensitive, shade-tolerant trees starting to pop up, represented by the cool mint green trees in the understory. And that's what we have today: overstory, oak, hickory, understory of these mesophytes, and of dealing with this forest conversion now as the overstory oaks and wink out and are replaced. So one thing I want to talk just very quickly about is just thinking about the profound effect it's had on animal species that co-evolved with these systems. In the past, you had acorns, hickory nuts, American chestnut, of course, there, and to a certain degree, seeds from these larger pines. Eastern white pine comes to mind. Where are we going today? Well, we're going to these small-seeded individuals, such as red maple, sugar maple, black cherry, black gum, things like that. So I just want to point it out to the group that not only do we have major ramifications regarding the plant world, this is affecting the wildlife world. And there's going to be winners and losers because of this transition. Another reason why we should manage for the oak resource, of course. Disturbance-mediated accelerated succession, or simply what happens if stands are harvested in their current state. Oak overstory, mesophytics in the understory, you take the axe to them. You know, this is forestry 101, people, right? What you see is what you get. If you have an understory that's laden with shade-tolerant mesophytes, you're just going to accelerate that transition when you harvest the oaks from the overstory. And this also pertains to blowdown events. That's documented by Holtz, Miller, and others as well. So whether it's the axe or blowdown, it's just going to accelerate this transition. So what to do? Well, prescribed burning is definitely needed, but oftentimes it's not enough for restoration of pyrogenic ecosystems. We can turn to a study at the Morton Arboretum in Illinois, a very rich in mesic system, that even after 20 years of annual prescribed burning in the understory, coupled with some thinning that they did there too, it failed to produce the conditions necessary for oak recruitment. Can you imagine that? Putting fire in the system annually for 20 years, really, and not getting the results that you wanted. Oak seedlings only representing about 2% of the relative density. Oak saplings virtually non-existent. This is your oak sapling bottleneck, incidentally, that's manifesting itself here. So what is that telling us? At least in these rich mesic sites, which is equivalent to your cove forest over there, is that fire is really, sunlight is the limiting factor here. So just by burning these sites alone, if you're not knocking holes in the overstory, it's not necessarily going to help your cause. So what to do based on that information and others is that you want to thin these stands. You want to discriminate against non-oak species, of course, as you're thinning those stands. You want to get a prescribed burn in there, and zoinks, it didn't work. It's still laden with these mesophytes. You know, they have the ability to sprout too. So what's needed? Thinning, and you're going to have to burn. You're going to have to burn repetitively, slowly knocking out those fire-sensitive mesophytes. Oftentimes, you're basically scarring the tissue at the base and wrapping around until they die. You wait for a good mast year, you hold off fire, and voila, there you go. You have your oak regeneration that just took place, and over time will mature into a forest. Now, I want to point out a bifurcation here, people, which is very important, because oftentimes we manage these in forested conditions. But didn't I say that historically we're dealing with woodlands, and we're dealing with a very diverse understory, which we don't see any longer? They're in close canopy forest conditions. Well, it's very important that we recognize that. And for timber management purposes, yeah, surely we want to manage for forested conditions, right? We want to have maximum stocking along the way. We can have merchable thins that take place before the final cut. So it's wash, rinse, and repeat, going through this process, over an 80 to 100 year period. But again, for ecosystem restoration, specifically oak ecosystem restoration, you really need to maintain open conditions, and you have to do that with burning almost immediately. After about 10 or 15 years after you get this initial regeneration event, you have to get fire back into those ecosystems because you want to maintain some openness, sunlight to the forest floor, and of course, maintain your grasses, forbs, and shrubs. That should be part of that ecosystem. When you want regeneration, you just do a periodic pause. Of course, you affiliate that with a mast year for oak regeneration in the future. And for oak woodlands, you probably only need to do it once every 50 years or so. But they're very important to have these different age cohorts, because as the older ones senesce, you'll have a younger groups to take their place. These are not mutually exclusive, right? Timber management, that's going to be generating the funds. And what you want to do is take some of those funds, if you can, keep them on site and use them for oak restoration, because you're really not generating any money in the oak restoration side of things, right? Because of the fact that it takes a lot of intense work, a lot of burning to keep those systems going. So I suggest at a landscape scale that you use these two things. You have X number of percentage of that land that's in the timber base generating funds, and you shunt those funds over to a percentage of that land base to maintain these systems in an open state, true oak ecosystem restoration. Just want to quickly point out there's success stories out there. Seems like things are very bleak out there. This is from Mark Twain National Forest in Missouri. This is what you see off on the left-hand side, untreated. You have these continuous canopies, high density, shaded understories, the pauper ground floor. As a matter of fact, this is more robust than I normally see it. Normally, again, I'm just kicking leaves, deep leaf litter layer because you have no burning taking place. This represents a thinning in 5 burns over 15 years, and look at how the conditions have changed here. Open canopy, historic densities, highlight conditions, robust diverse understory, negligible leaf layer, litter layer because of the burns that are taking place. Just very quickly, current trends regarding prescribed burning. We can quickly jump to the MON. Down here, we see that overall, all these units, there's an upward swing. This spans 11-year period, basically 2007 to 2017. So this is encouraging to see that at least where we have pyrogenic ecosystems that are dominated, particularly in the southern tier, central portions of our region, that we are increasing burns. And definitely that's the case with the MON. How do these current levels equate to historic regimes? Well, we turn to land fires, historic mean fire return interval map. Here you see that map here, red colors, very frequent fires, of course, radiating to green where fire was not as important on the landscape. And this is where the frightening thing is when you make these two comparisons. Right now on the MON, based on that 11-year average, we're only burning a little over 1,000 acres a year. That might have changed over the last couple of years. I doubt it with COVID though. Predicted historic annual mean is over 73,000 acres. That's based on land fire again, the estimation of how much acreage burned. So roughly we're only burning, well actually, percent currently. I'm going to take these numbers just very quickly and convert it into a graph just to emphasize that at this rate, it takes us 50 years of prescribed burning to equate to 1 year, which was burned historically. Mind-blowing. Next, I just want to point out a study, a recent study by Mike Stamball and others, and this is based on fire scar information. And this has to do with a wave of fire that followed European settlement. The stars that you see on the graphic here, this is information from central Pennsylvania, are when European settlement basically started. There was a certain degree of offset within this particular region when settlement occurred. The red line here basically just points out when European settlement took place. The big take-home message with this really cool study is the fact that when Europeans came on the scene, timber operations, whatnot, fire increased, right? And that's very consistent with the story I just mentioned to you guys earlier here. So there's a strong correlation with increased fire with European settlement on this landscape. Truly, it was a wave of fire, and it's a wave of fire that indeed took place across West Virginia. The reason why I point that out is that I want to look at the oak resource over different timelines here and correlate that with temperature. The temperature that you see here comes from Greenland ice cores, hence the negative values here, but at least it gives you what's happening over time, right? Extractable over a North American continent. Anyway, if we look at the very long time period, 10,000 years ago till now, we see that we went through some major changes. We have early Holocene warming that took place up to about 8,000 years ago. The hypsothermal or the Holocene thermal maximum spanning a long time period. This is during elevated warming and dry conditions, followed by neoglacial cooling starting about 3,200 years ago. This is basically takes place. This is very routine, right? You can go past interstitial and past glaciation events, and this is normally what happens. This is the setup for the next glaciation event, which we should be in the midst of right now. Probably not. Just looking at oak importance, we see with this early Holocene warming, we have an increase in oak importance in the eastern United States. What's happening here, it's going from southeast refugia down in Florida, Georgia, Alabama, those type of states, and the oak resources migrating northward into the central portions of the United States. At that time, the warm, dry conditions allowed it to maintain itself at a high level. But one would think with neo-cooling, what should happen? Well, this resource should start waning, right? Because conditions are less conducive to it. Well, it didn't. And we think the reason for that is that Native Americans really were key species basically on this landscape. They were using fire actively to manage landscapes in the oak resource. Keeping conditions open, very good for their prey base of bison, elk, deer, species such as that, and also promoting acorns and mass production to eat. Here's that little bubble. That's why I shared that other story by Stambal and et al., where Europeans came on the scene, and you had this actual increase of oak importance because you had more fire on the scene. And now over the past 50, 60 years, we see oak importance plummeting. Giving greater resolution past two with these different climatic events interbedded in this time frame. It's very interesting that during the Little Ice Age, when there was tremendous cooling in a wetter environment, we actually have this bump of oak importance. Now remember, we're dealing with a xerophytic species, right? And one that is warm or hot base. So this is very telling in that it was a disturbance really driven species or genera or genus that was promoting oak over time. It wasn't really linked with climate in any way. Now in the Anthropocene with elevated temperatures, we should see better conditions for oak, one would think, but here it's plummeting. And again, this corresponds with fire suppression. Very little to do with climate. Lastly, on the bottom, our highest resolution going 500 years. Note that this ice core temperature ends about 100 years ago. So if we would project this into the last 100 years, it would just keep on going up. Okay, I just want to point that out quickly. But again, major impact Native American depopulation, complements of old world diseases that were brought over. Up to 80 to 90% of Native American populations went away because of those diseases, along with warfare and social destruction, basically, that were affiliated with all these things. With the great cutover and landscape burns going from New England over to the Midwest, West Virginia, actually, temporally speaking, probably more affiliated with the Midwest. But you had this increase in oak importance, again, due to all the cutovers, the burnovers, and oak benefited, whereas pine was actually a negatively impacted. So it's basically niche recovery here or expansion by oaks. And then fire suppression kicking in about 50, 60 years ago. And you know what's happening, oak importance going down. So I really wanted to set the stage here long term of this interrelationship between oak and temperature. And you can see that relationship was strong initially after deglaciation and warming, but other factors have been controlling oak importance outside of climate envelope. I want to point out this recent study is quite interesting. This has to do with the modeling of species distribution over Pennsylvania. The dots that you see here is FIA data. The green dots represent those areas that have always been forested. The yellow or the orange dots that you see here, those are abandoned croplands that have taken place at a very low level, and the orange represents abandonment at a very high level. Okay, so this is the database they were using to make predictions of or modeling species distribution. The interesting thing here, and this corresponds to what I just went through, when you're dealing with the oak species here, it's amazing what they're linked to versus these mesophytes on the bottom row. Quickly to point out, these are different models that have been run. The most valuable variable explaining these models are on the top, and the least one is on the bottom. This is just ranking the top 10 of these variables from top to bottom. Most important to least important again. Blue represents climate, orange represents land use, gold soil, and this gray topography. And look at what's really driving the oak species. And the ones that are most interested here are northern red oak and white oak. They are directly linked to land use. Those are the things that are used in these models to improve them and to explain the occurrence or presence and absence of white oak and northern red oak, coupled with soil properties. If you look for climate, those things are occurring in these models, but they're much lower along these diagrams, within these diagrams. Now contrast that with these mesophytes. Look at where the blue bars are popping up very early in the game, right? These are very important variables that are affecting these mesophytic species, red maple, sugar maple, beech. So basically what I want to convey to the group here is that climate change perhaps is going to have a more dramatic and profound effect on our competitors versus oak. That's very, very important. And if we just turn to the good old tree atlas, this was brought up previously. I incorporated the major primary species that you find in West Virginia: white oak, northern red oak, black oak, chestnut oak. Shared to various degrees previously. The adaptability of all these species seem to be very high. If when they model future suitable habitat, basically everything is increasing from small to perhaps substantial increasing for these 4 species. The capability to cope is very good across the board. Infilling capacity, very good to excellent. This is kind of interesting in my mind, because in order for infilling to oak to take place, you're still going to have to deal with these competing species. So I need to learn more, I guess, of how this was calculated, because I question that a little bit. If you don't have good seed banks and control competitors, I don't know if you're going to get this level of excellence, if you will, regarding regeneration. That's my own philosophy there. And lastly, let's go to the authorities, including Patricia, who's on the line and hosting this. And just want to share a few things, just focus in on the text that's red here under the enhanced fire risk subcategory. They recognize how important fire was in the past, especially for oak dominated communities. And by the end of the century, most models are projecting an increase in wildfire probability, okay? So quite frankly, that bodes good for oak. Although I say that with caution, right? We don't want to see hundreds of thousands of acres burned up and people hurt or injured or deaths and property consumed, but this is what is being projected. And the increase in wildfire risk might be greatest in southern Ohio. And here's your state, West Virginia and Western Pennsylvania. I found that quite interesting. I wanted to share that with the group. And under the subcategory of shifts in upland forest composition, forest communities featuring a greater abundance of oak and southern pine species have generally been assessed as being less vulnerable to projected changes in climate, okay? And that's very consistent, what you've heard previously and what you've heard earlier in this presentation. And these systems are adapted to hot, dry summers and frequent fires, which are predicted to increase across much of the region, okay? So these changes in climate seemingly align themselves well with oaks. So here we are, finally, summary, end of presentation, yippee. Oak is a pyrogenic and also a drought tolerant genus based on tree life histories and physiological characteristics. Fire formerly played a very significant role throughout the East, and we're currently burning only a fraction of what is historically burned. Fire suppression efforts over the last century have been extremely effective to the detriment of fire-dependent plant communities, particularly our poor ground flora. Fire suppression has had these cascading effects, changing open lands to closed canopy forests and allowing fire-sensitive, shade-tolerant species to prosper, especially maples, at the expense of oaks. Both prescribed burning and thinning are needed in order to maintain oak communities. Use timber management receipts, if you can, to generate the funds needed for long-term oak ecosystem restoration. And remember, take on a landscape approach here, where you integrate both areas for timber management, generating funds for the maintenance of these open oak woodlands. And lastly, oak is very much capable of coping with a hotter and drier future climate. It's based on all the modeling that we've done. That's been shared earlier as well. However, certain regeneration parameters still need to be met, right? Prescribed burning or fire is very important. We want to get high light conditions down to the forest floor in order to get oak to regenerate and recruit from seedling to sapling, sapling to mid-story, and eventually into overstory. And you really have to keep your eye on limiting competition. So with that, back to you, Madeline or Patricia, whoever wants to take it over at this time. I don't know where I'm at time-wise. I'm probably over. I apologize for that.
You did fantastic, Greg. You are actually right on time. We have about 15 minutes for question and discussion related to this topic. We built in a lot of time for your presentation because it's a pun intended hot topic in West Virginia right now. So if folks would like to unmute, you are welcome to ask a question live. Or make a productive comment. Otherwise, you can also type your questions into the chat box and we will relay your questions to Greg as well. So the floor is open.
I have a question if nobody else is asking. Can you hear me?
We can, Rick. Go ahead.
Awesome presentation, Greg. Really cool. I'm from the forest health side. A couple of things came up is, man, oak's time maybe have come is probably what I got out of that. A lot of what I heard you saying is succession is, and humans being part of that succession are moving us away from oak. And it sounds like you really got to work hard to keep it and sustain it. And I understand the viability of species is important.